Hello, welcome back everybody to the second session of this year's SU2 Conference. I'm Daniel Mayer. I'm a senior engineer at Bosch in the Silicon Valley, and I'm a board member of the SU2 Foundation. And it's my pleasure to host this session today. And with that, I would like to introduce our first speaker, Ishaan Desai. And he's from the Department for Usability and Sustainability of Simulation Software of the Institute for Parallel Distributed Systems at the University of Stuttgart. So please take it away, Ishaan.
Hello, everyone. I hope I am audible and it's clear. Yes, so today I want to talk about coupling SU2 to other simulation software using the preCICE library. Next slide, please. Okay, so I will give a brief introduction on preCICE. Then I will talk about a new software package, which we in the coupling world here call the adapter, so an SU2 adapter for preCICE. I will quickly show an example where SU2 is coupled to a structural solver using preCICE. And lastly, some links and useful stuff on how to get started with such a coupling. Next. So a brief introduction to preCICE. So I will take you through a coupling workflow of how things usually progress with preCICE. So the two major things to understand about preCICE is that preCICE is a coupling library, so it does not have an executable of its own. So when two or more solvers are coupled with preCICE, the solvers are still executed on their own, and the coupling happens by a connection with the shared library file of preCICE. So the library approach is an important part. And second is a partition black box philosophy. So preCICE does a partition black box coupling. So it really disconnects the two or more participants which are being coupled, and also ensures that the coupling is minimally invasive. So minimum additions to the code are necessary to couple a code with preCICE. So let's start with the CFD solver next. Yes, and assuming we want to couple it to a finite element solver, this can be a typical fluid structure interaction problem. Next. Yes. So the green blocks is what I just explained. So the coupling will happen through this libpreCICE shared library file. So this is the main connection line between the two solvers. And on the left-hand side, between the solver and libpreCICE, you see an additional block called the adapter. So an adapter is a software package that is kind of born when a solver is coupled again and again with preCICE. So certain functionality needs to be added to a solver for it to be coupled with preCICE. For example, when a part of a mesh is defined as a coupling mesh in preCICE, data needs to be collected from that mesh in each time iteration and transferred to preCICE. So a data collection and similarly a data application needs to be done. So this functionality has to be redone in every time a solver is coupled with preCICE. And eventually this can be extracted and supplied as a different software package. So we support adapters for multiple solvers which are coupled again and again. You also see that preCICE is not restricted to CFD and FEM solvers, but in-house solver codes and also in the near future, mesh-free particle codes can be coupled. Next. Yes, so some names here. So on the CFD side, we support OpenFOAM and SU2 as official adapters. So we supply official adapters. We maintain them in the open source and as free software. On the FEM side, we also have many names like Deal2, Phoenix, Newtils, and more. What's an important point is this lower left corner. So for the in-house solvers, the preCICE source code is in C++, but we have API which is available in all major programming languages. So users are free to write their code in whatever language that suits them, and it can be coupled with preCICE. Next. Yes, and the main block is preCICE itself. So preCICE, as I already said, is a partition multiphysics simulation library. It offers completely peer-to-peer communication system. So a coupling done through preCICE can be scaled to massively parallel applications. It has data mapping schemes for data interpolation on both sides, and also different coupling schemes. I won't go into the details of this due to the time, in interest of time. Next, please. Some unique selling points of preCICE. So as I already said, there are multiple ready-to-use solver adapters, SU2 being one of them, and I will describe it shortly. preCICE scales to massively parallel applications, and we have shown that through various publications. We have robust quasi-Newton coupling schemes to ensure that complicated multiphysics can also be coupled in a black box fashion. arbitrarily many components can be coupled. So it's not just a coupling between two solvers, but more than two solvers. The coupling is minimally invasive. So as in the introduction you already saw, I come from the Department of Usability and Sustainability of Simulation Software. So this minimally invasive coupling is a philosophy which is tied towards building reusable and open source and sustainable software. And of course, preCICE and all the adapters are free and open source software available on GitHub. We also have a growing user community, which you can see from the picture on the right. So it's a preCICE workshop, a yearly workshop that we conduct. And this is, of course, in the online format from this time. So I now come to the SU2 adapter for preCICE. So first and foremost, the source code is available on GitHub. All the adapter related functionality is available in its own repository, and the way this is integrated into SU2 is that it needs to be copied. The files need to be copied to specific locations in SU2, and then SU2 needs to be recompiled. So we have given a script to do this. So if the SU2 source path is supplied, then there's a script which does this automatically. The adapter is kind of integrated into SU2 in such a way that we have certain configuration variables which can be used to turn the adapter on or off. So when the adapter is turned off, SU2 will run as a normal SU2 installation. As already said, there's also support for multiple coupling interfaces. Point number 5 is quite critical, that the adapter currently supports reading of displacement values and writing of forces. So this mainly comes from a fluid structure interaction point of view, where SU2 is then the fluid participant which is reading displacements, computing through all the differential equations, getting the forces on the coupling boundary and writing them back. So we will talk a bit more about this later. And also currently SU2 supports, the SU2 adapter is built to support the version 6 of SU2, which is quite, I know, quite old, but that's where we also have a note for a help required. So we at the preCICE team at the University of Stuttgart and the Technical University of Munich in Germany, we are experts in coupling and not a lot of expertise in SU2 itself. And that's why this is kind of a call for the community to help us kind of get some help to make SU2 compatible with the latest versions, the SU2 adapter compatible to the latest SU2 versions, also to add the conjugate heat transfer cases, for example, which would involve adding functionality to read and write temperature and heat flux and such. One important thing I want to note here is that there was some work done about integrating the SU2 adapter into the SU2 source code by Matthias Freimuth in Germany, but there was no update on that. So I was informed of this quite recently by a past colleague of mine. On the right, you see a quick snippet of the configuration file. So it's a typical SU2 configuration file, but now you see some preCICE variables there. And the first one, the line 15 being this preCICE usage, which can be turned on or off, and then other names which are required by preCICE. Next. So here I show an example case of a fluid structure interaction coupling with between SU2 and a structural solver written in the finite element library Phoenix. So the left schematic shows the domain. So we have a fluid domain, and within that there is a perpendicular flap which is attached at the bottom. This is an elastic flap which will bend on receiving forces from the fluid. So on the left side domain of the fluid, we have an inflow, and on the right an outflow. So there will be a flow from the left to the right, and in each time iteration SU2 will compute the fluxes on this highlighted blue boundary over the flap, and these fluxes will be transferred through preCICE to Phoenix. Phoenix will solve the structural problem, compute the updated displacements, send them back to SU2, which will be used to modify the mesh. And you can see the corresponding results. So as we have flow, and when we calculate the unsteady problem up to a certain time, we see that the flap is bent, and correspondingly the SU2 mesh has also deformed. One thing is that important thing to note here is that we have this same example also solved with SU2 and Calculix, SU2 and Deal2. So in the tutorials repository of the preCICE project, we kind of exemplify that changing solvers is not really a problem when you are coupling with preCICE. We also have more cases coupled with SU2, which you can view in the repository. Next. So some last links before I close. The preCICE source code is available on GitHub, and so is the SU2 Adapter source code. The links are in the first two bullet points. For user documentation, testimonials, and the tutorial examples, we have the preCICE.org website, which has been recently updated, and all the documentation is at its latest version. We have a range of tutorials in the preCICE.org tutorials and also the corresponding tutorials repository on GitHub. So this is a nice starting point when somebody wants to just have a look at how solvers are coupled with preCICE, and when they have their own code, for example, they have their own SU2 code and they want to couple it. For some initial discussions or some help, we have a discourse forum where you can ask questions, have technical discussions, and for quick help, we also have a Gitter chat room. Next. Yes, so I come to the summary. So I talked about preCICE as a black box partition coupling library, having ready-to-use adapters. Then I quickly described the SU2 adapter in a very brief, and also showed you an example of how SU2 is coupled to other software, and also some useful links. And yeah, I close by showing some more links about our Twitter handle, our discourse forum, our YouTube channel, and my email for further communication. So thank you very much.
Thank you very much, Ishaan, for this nice talk. Also, great job in keeping the time, so we have some time left for some questions. Miles Morelli comments that at Politecnico di Milano, we have developed a preCICE SU2 adapter for version 7.1.1. We are using it for rotor blade aeroelasticity problems by coupling MBDIN and SU2. It is currently working with both radial basis function mesh deformation and the linear elasticity mesh deformation technique. So maybe you guys can connect. Also one comment from Pedro Gomez. He suggests to join the developers meeting, and he says that helping is our middle name.
Yes. Yes, one quick comment on the Politecnico di Milano group. So yes, we are in talks with regarding the MBDIN adapter, and I really hope that we can also get into some form of connection for the SU2 adapter. So yeah, thanks for that information. And yeah.
Okay. Then one more question from Etienne Loriot. I hope I pronounced this correctly. Sorry if I did not. And the question is: are there communications through preCICE performed with MPI communications? If so, how do you manage coupling of commercial codes which generally are compiled with different compilers and MPI implementations? Is it possible to couple codes which have a different compiler and MPI implementations / versions requirements?
Yes, so it is true that we have attempted and struggled a bit to couple commercial codes like LS-DYNA, ANSYS Fluent, and others, but what we do is that we maintain preCICE compatibility for a range of MPI versions. So what's critical in such an application is that preCICE and the solver or the software being coupled need to point to the same MPI. But we have a CMake installation of preCICE, and we give a lot of freedom to the user to supply MPI paths and point to the MPI that the user wants. So that's how we try to cope with having compatible MPIs and linking issues.
Okay, thank you. And then one more question from Ole Burkhardt. He's asking, is there also adjoint support for the couplings that you have presented? What is the main difference between preCICE and OpenMDAO that we've just seen from your point of view?
Yeah, so okay, that's a bit tough. So I followed the talk before, but I would have to look at OpenMDAO to kind of give a good qualitative answer to that. As far as I could see, in preCICE, we really try to give a lot of freedom to the user to keep it partitioned and black box, and that's something that we try to cultivate. So I would be up to discuss that comparison maybe later on or over email.
Okay, and can you maybe also comment on the adjoint support for the couplings?
Adjoint support, I would also get back to you on that. So I'm not aware of adjoint support out of the box, but I need to check in with my colleagues and get back on that. Yeah.
Okay, then thank you very much.